So how do these ideas of monotone and bounded fit in with the convergence of a sequence? Our theorem is if a sequence is bounded and monotone, it converges. And I want to look at this a little bit more specifically. So if our sequence, a sub n, is increasing and it has an upper bound, then our sequence converges. Right, and that makes some sense. So if our sequence has an upper bound and it's steadily increasing, okay, it's going to settle around this upper bound and we're going to get our convergence there. Okay, and similarly, if our sequence a sub n is decreasing and it has a lower bound, our sequence a sub n also converges. Right? So if I have a lower bound here and my sequence is decreasing and coming down, okay, it's going to converge somewhere around that lower bound, perhaps a little bit higher than that, but it is going to converge. Okay, so with that in mind, we're going to take a look at our sequence, the square root of n plus 1 minus the square root of n, and we're going to show that it's decreasing and bounded below, and then we're going to talk about what that tells us about the convergence. To show decreasing, we can use the first derivative. So I'm going to switch this over into x. So I have x plus 1 to the 1/2 minus x to the 1/2. And again, the reason we're switching to x instead of using n is that n is a continuous function, right? So it's a set of dots, and we need continuity in order to find the derivative. So I'm going to switch to x, which gives me my continuity. So f prime is going to be 1 over 2 root x plus 1 minus 1 over 2 root x. Okay, and then we just need to decide, is this positive or negative? So since we know that 1 over 2 root x plus 1 is smaller than 1 over 2 root x. We know that because this is going to be a little bit bigger denominator. So the bigger the denominator, the smaller the fraction. Okay, I can take this and I can move this 1 over root x to the other side. 1 over 2 root x plus 1 minus 1 over 2 root x is less than 0. And since my derivative is less than 0, this is for all of my x greater than or equal to 1, I know that this is decreasing. Okay, so I've shown the first part, the decreasing part. I'm going to show the bounded part. And I'm going to use a similar kind of comparison with inequalities. So I know that the square root of x plus 1 is bigger than the square root of x for x greater than or equal to 1. And I'm going to subtract that square root of x over. So I have square root of x plus 1 minus square root of x is bigger than 0. And that's for all x greater than or equal to 1. Therefore, I know my function is bounded below by y equals 0. So I have that my function is decreasing and it has a lower bound. So this is going to tell me that this square root of n plus 1 minus square root of n sequence is also going to converge based on that.